Hello everyone, welcome to our very first Algebra 2 tutorial on solving systems of equations. We're going to begin by reviewing the substitution method, and I'm going to do an example with 2 variables and then another example with 3 variables. In the next video, I'll show you how to use the elimination method, and then I'll show a third video on how to use matrices. So with the substitution method, basically what we're trying to do is isolate one of the variables. And so if I look at the given system, right now each of these equations is in standard form, which means that none of my variables are isolated. I don't have an x equals equation or a y equals equation. But if I'm looking at my variables x in the first equation, or x and y in the first equation, and x and y in the second equation, I can see that this y has a coefficient of 1. It's going to be the easiest equation to solve for y. All I have to do is use inverse operations. Since this is a positive 2x, I can subtract 2x from both sides, and that leaves me with an equation where y is equal to negative 2x plus 4. I have seen students combining these two to actually get like a positive 2x. Remember, numbers and variables cannot be combined together with addition and subtraction. They're going to remain separate. So now that I have a quantity that represents y, I'm going to take this expression and I'm actually going to plug it in to the other equation. Make sure you put it into the other equation and not the same one. If I plug it into the other equation, then I have 3x, and what I'm going to do is I'm just going to copy the equation the way it's written, except instead of using y, I'm going to leave myself a little bit of room. And that's essentially what the first equation looks like. 3x plus 5 times something is equal to 13. And that something is the expression negative 2x plus 4, because that's what I'm told that y equals. So now that I've got this, I've got one equation that only has one variable. And the benefit to this is that I can actually solve for the variable x. I do need to follow my order of operations, though, to simplify the left-hand side. So to get rid of my parentheses, I'm going to use the distributive property and distribute 5 to both of those numbers. That means I'm going to have to bring the 3x straight down. 5 times negative 2x is going to give me a negative 10x, and 5 times 4 is going to give me a positive 20. And now that equals 13. I'm going to combine my like terms. Since they're on the same side of the equation, I'm not changing the signs. I can just combine them. That's going to give me a negative 7x. I still have the plus 20 equals 13. Now to finish solving for x, I'm going to use my inverse operations and the reverse order of operations, which would tell me to subtract the 20 first. And that's going to leave me with a negative 7x is equal to a negative 7. And if I divide both sides by negative 7, that means that x is equal to a positive 1. Well, that's awesome. Now I am halfway there. Once I know the value for x, I need to substitute it in and find the value for y. It's going to be easiest for me to plug it back into this equation because y has already been isolated for me. So that means that y is equal to 2 times x plus 4. And again, I'm just going to kind of leave the parentheses there to remind myself that I'm replacing x with 1. And so now I can simplify. 2 times 1 is simply 2, and 2 plus 4 is 6. And so the solution to this system is 1, 6. Because remember, the solution to a system of linear equations is just going to be a point. We can use the substitution method even if we have 3 equations that involve 3 variables. The goal is still the same. I want to reduce the number of variables I have in an equation so that I can solve for one variable at a time. So I'm going to look for the variable that is easiest to isolate. And if I look at all the values of x, y, and z, the only variable that doesn't have or has a coefficient that's not equal to, or that's 1, is x in the second equation. That is going to be the easiest equation for me to get x by itself. And all I need to do, if I rewrite it, so I have x plus 5y equals 9. All I need to do to get x by itself is to subtract 5y from both sides. And now I know that x is equal to negative 5y plus 9. Now before, when we were only dealing with 2 equations, I only had to substitute the quantity into one of them. Now that I have 3 equations, though, I'm actually going to need to substitute that value for x into both. Oops. I forgot that my x and z variables in my third equation are not written in order, so they're not written in the proper form. So basically what I'm going to do is I'm going to substitute in the quantity negative 5y plus 9 in for both of those x values. So let's go ahead and do it for the first equation. So normally I'd have 2 times x plus 3y minus 2 times z is equal to negative 1. But I'm replacing the x with negative 5y plus 9. All right. And now I'm going to simplify. I have to distribute the 2 to both terms. That's going to give me negative 10y plus 18 plus 3y minus 2z equals negative 1. And now I'm going to combine my like terms. Again, the negative 10y and the positive 3y are on the same side of the equation, so I don't need to change the sign when I put them together. That's going to leave me with a negative 7y plus 18 minus 2z equals negative 1. If I want this in standard form, that means I've also got to get that 18 to the other side of the equation so that I have my variables on the left and my numbers on the right. To move the 18 over, I'm going to subtract it. And that's going to leave me with a negative 7y minus 2z, and that's going to equal a negative 19. Well, that's great. I've eliminated the x variable from that big equation. The problem is I still have an equation that has 2 variables in it, and that doesn't enable me to find the value of y or z. I need another equation with a y and a z in it so that I can put them together and solve that system. Because remember, you need the same number of equations as you have variables to figure out a solution. So now I'm going to move to the third equation, and I'm going to rewrite that equation and replace the x again with the negative 5y plus 9. So that third equation I haven't dealt with yet is 4 times z minus 5 times x, which I'm just going to leave in parentheses for now, and that is equal to 4. And I'm going to replace the x again with that same quantity, negative 5y plus 9. To simplify, I need to distribute the negative 5, so I'm going to bring the 4z down. Remember, I'm distributing a negative 5, so negative 5 times negative 5y is actually going to give me a positive 25y. And negative 5 times a positive 9 is a negative 45, and that's going to equal 4. So again, I still want to get this in standard form, and to make it line up with the other equation, I'm going to want to put my y term in front of my z term when I rewrite this. I also need to move the 45 to the other side. Since I'm subtracting, I'm going to use addition to move it. All right, so again, like I said, I'm going to put my 25y first, and then I have plus 4z, and that's going to equal 49. And that's my second equation. And now I have 2 equations, and even though I have 2 variables, they're both the same, so it's going to actually make it a little bit easier for me to solve. Now I'm going to put those 2 equations together. So I have negative 7y minus 2z equals negative 19, and I have a positive 25y plus 4z equals a positive 49. Now at this point, since both of my equations are in standard form, I'm going to go ahead and just use the combination method. And what I notice, if I'm trying to eliminate a variable, it's going to be easier for me to eliminate my variable z because the 2 divides evenly into 4. It's going to be less easy for me to figure out a value that both 7 and 25 can go into evenly to eliminate the y variable. So I'm going to go ahead and eliminate z. But I've got to remember, in order to cancel the z, the coefficients have to be opposite. I saw a lot of students that would get like positive 4z and positive 4z and think that they cancel. If you combine a positive 4z with another positive 4z, that leaves you with 8z. You need to make sure that you have opposite coefficients. So what I'd like is for this coefficient to be a negative 4, because if it's a negative 4z, it's going to cancel with my positive 4z. It means I need to double everything in this equation. And I'm just going to rewrite it underneath here. So when I distribute the 2, that's going to give me a negative 14y, and that's going to give me a negative 4z. I still have my equal sign, and now I need to multiply 2 times negative 19. And that gives me a negative 38. And now I'm basically just combining these 2 equations. The z's do cancel because I have one positive 4z and a negative 4z. They cancel. 25y minus 14y is going to leave me with 11y, and 49 and a negative 38 is going to leave me with an 11. And if I divide both sides by 11, I find that y is equal to 1. Once I know the value of y, I can plug it into the other equations to find the values of x and z. Let me just go back up here for a second. In fact, since I know the value of y, it's going to be easiest for me to plug it into this equation first to find the value of x. Because if x plus 5, and remember we just found out that y was 1, is equal to 9, that means that x plus 5 equals 9. And if I subtract 5 from both sides, that means that x is equal to 4. So now I also have the value of x. So if I know the value of y, I know the value of x, I can easily find the value of z. In fact, I can plug this value of x into this equation. And I know I'm sort of running out of space here. If I plug x equals 4 into that equation, it'll easily help me solve for z. I'm going to do that down here if that's okay. So we have 4z minus 5, and we just found out that x is 4, so I'm going to replace the x with a 4, is equal to 4. And if I solve this, well, negative 5 times 4 is going to give me negative 20. So we have 4z minus 20 is equal to 4. And in order to solve for z, I'll need to add 20 to both sides. And so I get that 4z is equal to 24. And if I divide both sides by 4, I get that z is equal to 6. So that gives me my third solution. I knew that x is 4, y is 1, and z is 6. And that is going to be the solution to my system. All right, stay tuned for the second video on solving using elimination.